What is the fetch-decode-execute cycle in digital electronics? Imagine a busy chef in a kitchen, constantly grabbing ingredients, figuring out what to do with them, and then cooking. This process is similar to what happens inside a microprocessor when it runs a program. The fetch-decode-execute cycle is the step-by-step process that makes this possible. It is the core routine that allows computers and digital devices to perform tasks. First, the fetch stage is like the chef reaching for the next ingredient. The microprocessor looks at the program counter, which keeps track of where it is in the program. It copies this address into the memory address register and sends a signal to the memory to fetch the instruction stored there. The instruction then moves into the memory data register and finally into the current instruction register. After fetching, the program counter increases to point to the next instruction. Next comes the decode stage. Think of this as the chef reading the recipe. The microprocessor interprets the instruction by splitting it into two parts: the opcode, which tells it what to do, and the operand, which is the data or address involved. The control unit checks the opcode to decide whether to add numbers, compare values, or jump to another part of the program. It also figures out which registers or memory locations are needed. Finally, the execute stage is like the chef actually cooking. The microprocessor performs the operations specified by the instruction. This could mean adding to numbers using the arithmetic logic unit, moving data from memory to a register, or changing the flow of the program by jumping to a different instruction. The cycle then repeats itself, fetching the next instruction and continuing the process. This cycle happens billions of times every second in modern microprocessors. Techniques like pipelining allow multiple instructions to be processed at once, making computers faster and more efficient. From an electrical engineering point of view, understanding this process helps in designing better digital circuits. It involves managing signals on buses, controlling data flow, and making sure each instruction is executed correctly. Knowing how the fetch-decode-execute cycle works is essential for building and improving microprocessors and embedded systems. It's the heartbeat of digital electronics, powering everything from simple gadgets to complex computers. Every time you turn on your device, this cycle is working behind the scenes, making sure your commands are carried out smoothly.